Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Den. Episode 11, Webhook Security and SSRF. Alice, webhooks, HTTP callbacks where an external service automatically sends your server a notification when an event occurs, are everywhere in modern SaaS. Payment confirmations, e-filing status updates, e-discovery notifications. What's the security concern?
Every webhook endpoint is a door you've deliberately opened in your perimeter. You're saying, external systems, please send me HTTP requests containing data I'll act on. The two threats we're covering today are 1. Someone forging those inbound webhooks to trigger actions in your system. And 2. SSRF, server-side request forgery, where an attacker tricks your server into making requests to places it shouldn't.
Let's start with SSRF. Give me the basic attack pattern.
Your server fetches URLs as part of its normal operation. Maybe it's downloading a document referenced in a webhook, or validating a callback URL during integration setup. The attacker provides a URL that points to an internal resource, your cloud metadata endpoint, an internal admin panel, a database that's only accessible within your VPC, your virtual private cloud, the isolated private network your services run in. Your server fetches it happily because from its perspective, it's just making an HTTP request.
And the most famous example of this going wrong.
Capital One, 2019. An SSRF vulnerability let an attacker query the AWS instance metadata service at 169.25.4, TINE 169.25.4. That metadata endpoint, metadata being configuration data about the server itself, hands out temporary IAM credentials, identity and access management keys that grant permissions to cloud resources, to any process on the instance. The attacker got those credentials and used them to exfiltrate 106 million customer records from S3, Amazon's cloud file storage service. A single SSRF, 100 million records.
That's why SSRF made the OWASP Top 10, the Open Web Application Security Project's list of the most critical web security risks, which we discussed in episode 3, as its own category in 2021.
Exactly. And for legal SaaS, the attack surface is particularly nasty because you can't just block all outbound requests. Your system needs to talk to court e-filing APIs, payment processors, e-discovery platforms. Those integrations are the product.
So, how do you defend against it?
Layers. At the application level, validate every URL before fetching. Resolve DNS, the domain name system that translates website names into IP addresses. Check the resulting IP isn't in private ranges. No 10.x, no 172.1631.x, no 192.168x, no 169.2254.x, no localhost. Pin the resolved IP so a DNS rebinding attack can't swap it between validation and connection. At the network level, egress firewall rules, egress meaning outbound traffic leaving your network, that only allow outbound connections to known good CIDR ranges, CIDR being the notation for specifying blocks of IP addresses. At the cloud level, enable IMDS v2, the newer version of the cloud instance metadata service, on every instance, which requires a token that SSRF typically can't obtain.
What's DNS rebinding? That sounds like it bypasses the IP validation you just described.
It does, if you're not careful. The attacker controls a DNS server. First lookup returns a public IP, passes your validation. Second lookup, when your server actually connects, returns a 169.254, 169.254, or whatever internal target they want. The fix is, resolve once, pin the IP, validate it, and connect to that specific IP address. Don't let the DNS resolve again between check and use.
Okay, now the other side. Inbound webhook forgery. How do you verify a webhook is legitimate?
HakeMac signature verification. HakeMac stands for Hash-Based Message Authentication Code, a way of computing a fingerprint of a message using a secret key so you can verify both who sent it and that nothing was tampered with. The sending platform and your system share a secret key, established during integration setup. Every webhook request includes a signature header. That's the HMAC SSJ256 of the raw request body computed with the shared secret. You recompute the HMAC on your side and compare. If they match, the sender possessed the secret. Use constant time comparison, meaning your code takes the same amount of time to respond whether the signature is almost right or completely wrong, to prevent timing attacks, where an attacker measures tiny differences in response time to guess the correct signature one character at a time.
And the timestamp piece.
Critical. Without timestamps, a valid webhook can be replayed forever. Stripe's model is the gold standard. The timestamp is included in the signed payload, so it can't be modified independently. You reject any webhook where the timestamp is more than 5 minutes from your server's clock. That gives you a narrow window for network delays while preventing replay attacks.
What happens in legal tech specifically if webhook verification is missing?
Scenario 1. Your e-filing integration accepts unverified callbacks. An attacker sends a forged filing accepted notification for a document that was actually rejected by the court. The lawyer thinks their motion was filed. It wasn't. They missed the deadline. Scenario 2. Payment processor webhooks. A forged payment received notification marks the retainer as funded when no money actually moved. The firm starts work on an unfunded matter.
Both of those are genuinely harmful, not theoretical at all.
In scenario 3, e-discovery, a notification arrives saying the production set is ready for download at a specific URL. If that URL is attacker-controlled, either your server fetches malicious content or the request headers you send, which might include auth tokens, get captured by the attacker. That's the SSRF connection. The webhook is the entry point. The outbound fetch is the exploit.
So the two threats are actually deeply connected.
Exactly. They compound each other. Unverified inbound webhooks can contain URLs that trigger SSRF when your server processes them. You need both controls. Verify the webhook came from who it claims, and validate any URLs in the payload before fetching them.
Right. What's the practical implementation look like? Give me the checklist.
5 things. 1. Every webhook endpoint verifies HMAC signatures with constant time comparison. 2. Timestamps checked. Reject anything outside a 5-minute window. 3. Idempotency keys. Unique identifiers stored so replayed webhooks are detected and ignored. 4. Any URL in a webhook payload goes through DNS resolution, IP validation, and egress allow listing before your server fetches it. 5. Log everything. Source IP, signature validity, processing result. When something goes wrong, the logs are how you reconstruct what happened.
Yeah, and for teams building on cloud infrastructure.
INDS v2 on every instance. Non-negotiable. VPC egress rules restricting outbound traffic to known integration endpoints. And if you're using a webhook delivery platform like Spix or a managed gateway, let it handle the signature verification infrastructure so your application code doesn't have to re-implement crypto primitives.
Next episode, we're covering browser security headers, COR, CSRF, CSP, the alphabet soup that protects your users' browsers.
Where misconfigured headers turn your client's browser into the attack vector. Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.